this recording. Okay, so you remember in last class what happened? This state, right? When it's going to sleep, right? Sorry, when it's going to waiting state, after wait, it's not coming back to runnable state, right? So what was happening here? So if you see the flow, right? I also explained in the video, last class video. So we are having here 500. Okay. So let's assume the main thread started. Okay. And then it's acquire a lock, and then it just calling notify all. And till that time, we are not reach to the waiting state for another thread. Okay. So what was happening? Like we not reach to the waiting state and we call notify. Okay. And that is the reason once it's going to waiting state, it's not coming back. Okay. Okay. Because basically we are
Okay.
not okay. Because once the states change, right? Once it's go to the wait state, we are actually not calling logically, we are not calling notify all. We are calling notify all before it's going to wait state. Okay. And that is happening
Okay.
because you see here I have given 500 millisecond. So 500 millisecond is it's like quick, right? And then it will come here. It's acquire a lock and then it's calling notify all. Okay. And that is the reason. And till then we are not reached to the waiting state for this thread. Okay. So what I did is I just increase the time here. Okay. So I make this thread to sleep for 6,000 milliseconds. Okay. And in between what happened?
Okay.
I make this thread to go into waiting state, right? And when we call this ts.25 all, it because the thread was in waiting state, so it's uh, ask whoever threads are in waiting state, a timed waiting state, they all can move to runnable state. Okay, and that is the reason this is moving to runnable state. So if you run it now, okay, and if you see here, so see it's a new state now, running state thread 0, time waiting state. Now main thread is running right here, and you
Yeah.
see here runnable state, right? So the order, right? Never
Okay.
worried about order because these are executing concurrently. So there is a very difficult to maintain
Yeah.
order. Okay. Okay.
Order. Yeah.
So today, okay. So you see, you can you can get this output in order. Okay. But if you get this output in order,
Mm-hmm.
it's nothing. There is like it's kind of sequential execution, right? Where one thread can get executed, then another thread will get executed. Understand? If a whole the thread will
Yeah.
get executed at the same point of time, then this is concurrency, right? Okay. So today
Yes.
we'll see some example. We'll learn about 1 second. Let me share my screen. The you are able to see my screen, right? Notepad.
No, it's yeah, now I can see your notepad.
Yeah. So today we are going to learn about synchronization. Okay. And this is the one of the most asked topic. Like interviewer love to ask question from this topic. Okay. So right now you see the previous example. If you see any thread example till now, whatever we have written, right, for thread. So we are getting thread. We are just calling the method, and we used to call it like multi-threading or concurrent execution, right? So let's assume you are having a let's assume this is a TV, okay, and at a time 100 user is consuming, right? This one you are allowing 100 user to watch at a time. So whatever, like 100 threads are consuming this resource, right? So because this resource is shareable, right, and it will not, like if one consume it, is there any impact on that thing? No, right? Like if I'm watching a match and if 100 people are watching at a time, there is no issue because this type of resource we can enable for multiple people, right? And at a time multi radios and this type of thing we can have for at a point of time 100 or 100 users can see that, right? And because this type of resource are, we don't need to make it thread safe, right? Thread safe means at a time only one person can access, at a time only one thread can access, right? Okay. So now let's assume you are having a news portal, and what you are doing, you are publishing a news. Okay, so you publish XYZ news, right? So at a time, lot of people can watch that news. There is no impact. Means thousand of people can read that news, but write permission with only one person. Let assume if write permission we can give for 100%. So if you are writing at the same time, 100 people will write at the same column, then what will happen? Then there will be ambiguity, right? You might get a partial information, right? So
Yeah.
I'm just giving these examples about, it's not example of thread concept, it's example of which type of resource we need behind synchronization, which type of resource we doesn't need behind synchronization. Okay. Okay. Now let's assume uh, Ali and Ram, right? Okay. So now what Ali did, Ali have in his bank account 10,000 rupees or 1,000 rupees. Okay. And he gave his debit card to Ram. Okay. And Ali also doing some shopping on e-com. Okay. So there is a X time. X time is there certain time, 12 o'clock or 11 o'clock. Both Ali and Ram did a transaction. So what is the balance in Ali account? 1,000 rupees, right? So,
Yes.
so the transaction amount for Ali is, who is doing a shopping on e-commerce portal, is 600 rupees. And Ram is same at the exact same time, Ram is withdrawing from ATM. Sorry, 600, not 6,000. Okay, because I'm taking example of, okay, okay.
1,000.
So what happened? So in the case of multi-threaded environment, Ali will also do his
Yeah.
transaction,
Transact 600.
and Ram is also complete his
Ram.
transaction, right?
Yeah. Yeah.
Because at the same time both are did, and they both are having access to withdraw module, right? And they can withdraw easily,
Yes.
right? But this type of
Yeah.
resource, right? Let us in the resource where we are doing withdraw money and all, that is very sensitive, right? And before doing a transaction, we need to check, right? Let us assume if
Yes.
balance is not, if balance is there, then you allow one transaction at a time. So how will do that? So there is a way to do that. Okay, that will learn. Okay. Now you may heard about Book My Show.
Yeah.
Okay. So let assume I am opening this app in my mobile. You are opening in your mobile, right? There is a sheet called 12C. So we both try to book, right? At the same time. So what happened? Like we both can able to book that one, right? Because the book ticket module function which is allowing to book a ticket is multi-threaded, right? It's not a thread safe, not thread safe. Means at a time multiple thread can access that one, right? Book.
Yes.
So what happens when I check at 12 o'clock, when you check at 12 o'clock, 12C is available. So we both make a transaction at the same time, and we both get the same seat. Then we went to a movie hall, and right now we are fighting for the seat, right? So this type of situation occur in past, and then they've invented a concept called synchronization. So from name itself, you guys can understand it's basically synchronizing the process. Okay. So basically it's synchronizing the process. So what happened? What it's saying, what synchronization did is, okay, let us assume you are having 12C and we both reach at the same time, right? So let us assume A1 and A2. Okay, two threads. So when you try to book that ticket, so let us assume a fraction of second also if A1 reach, right, before. So A1 will log this object. Okay. So always remember all the objects in Java have a lock, and synchronization is a process to enable that lock. Let us assume if you are having a uh, uh, okay, when you enter this method, right, book my ticket. So definitely will invoke that method with the help of some object, right? So let us assume object is A1. Okay. And when you try to access this one for your thread T1, it's enable the lock. So now T1 is inside and doing his work with the help of A1. Once your task is done, the lock is released. Now T2 will able to access this block. When T2 access, again it will check the seat is available. If not available, there is no issue. If available, they will book, right? So basically transaction is saying if you are having a thread T1, you are having a thread T2, and there is a synchronized block, either one thread can access at a time. Okay. Not the both of the thread cannot access at a time. So how we'll do that? Like we have talked, right? It will allow one thread at a time, right? And we all like we explain the concept. Okay, if there are three threads, then T1, T2, T3. So it will first whoever reach first, they will acquire the lock. They will do their task. Then they will release the object. Then T2 will go. Then it will acquire. Then it will do its task. Then it will release. Then T3. So basically there is order T1, T2, and T3 based on scheduling, right? So it's like first T3 will go, T2 will go, then T1. So there is a order, right? The basic funda is at the same time, three thread cannot access, right? Once at a time, like once at a time, a thread will get execution unit, or a thread can acquire a lock on the object. What is the lock? How thread is acquiring? We see all of this thing. Okay. Okay.
Okay.
Now, synchronization we are having in two levels. Okay, basically we are having two levels. There are other levels as well that we'll see. So one is method level. You can make your method synchronized. So what happens? The whole method will become synchronized. And second one is block level. So you know we are having two type of block, static block and non-static block, right? Okay.
Yes. Yeah.
And method also we are having two type of. So now we'll learn everything. For static block, what happened? For non-static static block, what happened? Okay. Okay. So before going into the details of synchronization, let us see the example where we'll see like okay. Okay. So you see this example, you guys are able to see this one, right? Okay. So now I have one bank account, okay, which is having a balance of 1000 rupees. Clear to you all? And then what I'm doing, I'm having a method called withdraw. Right. So I'm passing an amount. Let us say I pass 500. First, I will check. The balance is greater than amount. The amount that you are going to withdraw, right? If it's greater, right? Then what I will do, I will proceed further and I will say like I will print which thread is going to withdraw, and I'm doing a minus, right? When you withdraw, let us say 1000, withdraw 500. So not will have 1000 minus 500, right? So I'm doing that. And then I'm printing remaining balance. And who withdraw that one? Okay. If not else, then not even enough balance, right? Okay. So now this is a bank account. Now I have withdrawal thread. I have created a withdraw thread, right? Okay. So what happened, like how we can create a thread? We can create a thread by extending thread class and overriding run method, right? And what I did, I'm just uh, taking a bank account reference, creating a withdraw thread object and passing a thread name, right? Till here it's clear or any doubt? Bonita, Kritika?
Yeah.
Yeah,
Yeah. Till this is clear actually.
Okay,
Checking balance. Yes.
yeah. Then what I'm doing, I'm just overriding it, right? And I'm just running the loop. I'm run for 10 times. Let me run for 3 times. Okay, 3 times is enough. If not, we'll see. And what I'm doing, because I have this account, right? I'm calling withdraw method. What is this withdraw method? This method I'm calling, and every time I'm detecting how much? 500, right?
500.
Okay, so how many times you can detect? 2 times, right?
Yeah.
Now, because here I created 2 threads, right? Ram and Ali. One thread is Ram, one thread is Ali. And I will started both, right? So both will run. Ram will run 3 times, Ali will run 3 times, right? So 6 times. So we'll see like how it's
Yes.
happening. 6 times when we are trying to run what and all output we
Okay.
are getting. Okay.
Okay.
So now we'll see here. So what is our RAM is going to withdraw 500. What is the remaining balance? 500.
500.
Ali is withdrawing 500. RAM is going to withdraw 500, right? Okay. Now see here. Ali is not in a balance to withdraw. RAM is not in a balance, so 3 times here. So total, how many times you have withdraw? 1, 2, 3, right?
3 times.
3 times we have withdrawal. Okay. And how much amount we have? 1000. So if we withdraw 3 times, it is how much? It's a 1500, right?
Yes.
Okay.
But
Now,
it's 1,000, so its remaining balance should be okay. Fine.
hmm. So now what we'll do is, now we'll increase the activity. Okay. We'll make it 10 and we'll see. So basically, okay. So RAM is going to withdraw 500. Completed, completed, completed. Again 3 times we are having, and somehow we are getting here. Correct. But 500 deficient we are, right? So what I will do is, so what I said, like method level synchronization, right? So without synchronization, you will get this type of ambiguity, right? Because it's a transaction. So at a time, one thread can only, so one thread, only one thread should access this withdrawal method, right? If 3 thread or 4 thread will enter into the picture, they all will get 1000, right? And nowadays we are having quad core, 6 core processor, right? So at a time, 8 threads will run and they all will have their own set of memory, right? There is no memory sharing, right? So in that case, what happened? We will get uh, dirty read, right? We will get incorrect values and all. So what I did, we use method level synchronization. So what method level synchronization do? So let me use this, okay, and then let me run that, okay. So see here. So see, RAM is going to withdraw 500. RAM completed a withdrawal. RAM is going to withdraw 500. Remaining balance is 0.
0.
Now Ali is doing, keep calling this withdrawal. Every time what Ali is getting? Not enough balance, right? Again, RAM try to withdraw, and RAM is also getting not enough balance. So this order, the print order, maybe go up and down, right? Because it's a multi-threaded environment, but you can see that at a time only one thread is getting executed, right? See, RAM is going to withdraw 500. RAM completed, RAM completed. Now all Ali, and RAM. So how many times we did a withdrawal? 1 and 2, right? means we have done 1000 rupees of withdrawal, which is correct. Clear?
Yeah, it's clear.
Okay. So this is the okay. So now what we learn here, basically we'll see. So you seems like, see this synchronized keyword, right? This seems like we are synchronizing the method. No, it's not like, yes, we are synchronizing the method. Basically, what is happening? So when you call account dot withdraw, so this account is an object, right? So every object used to have a default lock, okay, which is disabled. Okay. So when you use synchronized keyword, right? So what happened when this object call this method, a lock enable, and a thread get locked, right, with this object. So once this execution is done, then only that thread will release that object. Once that thread will release the object, the another thread will acquire that object. Okay. So if you see here, output. So first Ram is acquiring and it's doing his task. Then it's completed a withdrawal. Ram is going to withdraw. Again, Ram is only acquiring and Ram is completed, remaining balance is 0. Then again Ram, and somehow it's get time, right? And then Ali is acquire that, Ali thread acquire that lock because Ram release, then Ali acquire. Then Ali is doing all this transaction. Just don't go with this order. Okay, it's go up and down. So basically first Ram acquire everything. Once Ram task is done, then Ali will acquire the lock and Ali will do his task. Okay, clear? Okay.
Yeah, it's clear. Yeah.
Okay, so now we are having, you guys are able to see my screen, right? So now we are having a method level synchronization, right? So if someone asks you what is method level synchronization, right? So we'll say that when you use a synchronized keyword, right, for both instance level or static method, instance method or static method, right? So both the method will become a synchronized method. Means we can use synchronized keyword for static and instance method. So you can use for static and instance method. Okay. So now we'll talk about instance method. Okay. So simply straightforward, like we have seen in the example. So what we are doing, we are having a modifier which is public, right? And then we can use synchronized keyword, and then whatever return type you can have. So let us assume having void, and then you can have your method name m1 and whatever. So this is for instance method. So what happen when thread reach here? Let us assume with the help of any object obj1. So obj1. Let us assume you need obj1 to invoke m1. So what you do, you enable the lock. Okay, you get inside. Let us assume this is T1. You get inside, you do your task. Once the task is done, when you are getting out of that method, okay, again you release the lock. So by default, lock is disabled. Okay, we enable the lock, and then once our task is done, we release the lock. Then again another thread come, T2 come, then T2 enable the lock and then release the lock. Like acquire the lock and release the lock. You can say that. Okay. So this is the process. Okay. But there is a slight difference when we are going with the static method. Okay. So when a static method synchronize, right? then the default object which we use to invoke the class will be locked. So you remember, like I always used to say, like when class is loaded, there is a default object got created, right? Bonita, Kritika.
Yes, it will create the default object will be created for a class.
So when you are doing synchronization with a static method, right? Because a static method can be invoked, right, with class name, right? So in that case, there is no object, right? So
Yeah,
the viewer will ask you, in that case, which object lock thread will
you
acquire,
will occur.
right?
Yeah,
Uh,
yeah.
So you will answer, when a static method is synchronized, then the default object of the invoking class will be locked by the current
Mm,
thread. Okay.
okay, okay.
Default object. When default object will get created, default object will get created at the time of class loading, right?
Yeah, yeah.
Okay. We'll go into the detail of that.
Okay.
Okay. Okay. So now this is we have, like we are having method level. So synchronization we can achieve in two levels. The first one is method level. Second one is block level.
Block level,
In method level you can achieve in a static method and
instance method.
our instance method, right? So okay. So when you are doing an instance method, we have seen the example. That is only the only thing is that in instance level we'll acquire the lock on the object which we are taking help to call the method, right? Means current object, the object that you created, right, recently, to invoke the method, right? But in a static method, you will acquire the lock on the default object. Clear?
Yeah.
Yeah. Okay. Now we'll go to block level. How many types of block we have in Java? You remember static block, non-static block, local block? Remember, right?
Yes, yes.
Okay. So now, how to achieve synchronization on block level? Synchronization on block level means, so let us assume you are having a method, right? So we are having a method called withdraw, right? Let us assume withdraw, right? So what we are doing, we are using synchronized keyword here, right? And when you use synchronized keyword here, the whole method will be synchronized. But due to certain reason, I don't want to, because when you make it synchronized, at a time one thread can access and there will be a performance impact, right? If everyone come in a queue, right, for certain things to do, it will take time, right? Correct. So what we
Yes.
so we like no, like we not block everything, will not block whole code of the method, will just block or make it synchronize a certain piece of code which is critical. Understand? So let us assume
Mm,
inside this method, I just want to log this line system.out.println critical. I'm just writing here. I can have a certain logic written over there, right? And then what I did here, I have synchronize keyword and I use this. This means the current object, right? Like that, we can write. So whenever you use a block level synchronization, always remember to pass object like this. Okay. So if you pass this, it will enable lock on this. If you pass, let us assume here you create any list, right? You create a XYZ. I'm just giving XYZ, AL equal to new XYZ object. And then you pass here XY AL, right? So it will enable lock on this AL. Okay. We'll see that. Okay. So basically, let us assume we are having withdraw method, and let me end here. And if you want to achieve synchronization on block level, this is the syntax, a block syntax, then there is a parenthesis, and inside that you pass your object on which you want to enable the lock. Okay. So what happened when you are doing a block level synchronization, then the object which you are passing as a parameter, right? So which object we are passing here as a parameter? So any object, let this also, or any object you created here, you can pass, right? As a parameter. So what happened? The lock will get enabled by the current thread. So whoever the current thread which is passing through this, right? It will acquire a lock, and then at a time only that a specific thread will get executed for this piece of code. Okay. Okay. So now we have learned about synchronization. Okay. So what is the need of synchronization? You guys understand or not? Like, forget about the coding and all. Okay. So what is the
Yeah,
need?
that I understand synchronization.
Okay.
If both the thread, if on more than one thread is, accessing a same platform, then ambiguity may occur.
Yes. So to avoid that ambiguity, we are having a provision of synchronization that we achieve in two ways. One in method level, another one is block level. On method level, we can achieve it static method, non-static method, right?
Yeah.
So we have seen already, we have seen the non-static method. In next, right? Probably 5 minutes left. So in next class, we'll see almost 4 cases, right? Where we can have with default object, okay? And then we can have a class level, like we can directly achieve that we lock on the class object, which is called default object. Then this with the current object, and temporary object also will create, and we'll try to demonstrate the use of that. Okay.
Okay.
So till 5 minutes left. So what we'll do? So other cases, right? We have to go through more cases which have all this, like when you are using static, when you are using non-static, when you are going with a temporary objects, right? Then how the lock will behave, right? How synchronization will behave. So all these things will do hands-on tomorrow. But today we'll at least whatever code we have written, right? So we'll go through that. Okay. So see, basically what I'm saying is this synchronization, right? So I will just remove this piece, and what I will do, I'm just trying to achieve a block level synchronization. Okay. So basically what I did in this whole method, right? So this part is critical, right? This one, right? So I did in,
Yeah.
so making the whole method as synchronization, what I did is just make this part, right? So it's randomly, so it's not like you have to think through which part is supposed to, and what is the implication, what is the nature of your code, right? You need to, like, there is scenario where 100 people can read a balance at the same time. Reading a balance, right? Even you got wrong balance, there is no issue. When you are actually going to make a transaction, right? Let us at the same time we both check the balance. It's of 5,000 rupees. We got very happy. We both got very happy. And what we did, we both try to buy 5,000 rupees of stuff, right? But while buying, because buying is critical, right? Buying is actually making a real-time transaction. So in that case, that piece of code only will need to be in synchronization block. So there this block level synchronization will help. Okay. So we'll see how it's behave when we are doing block level. So remaining 0, Ali completed, right? Ram completed. So 500 and this minus 500. So here also a bit of issue. 1 second. Right? Because what happened, like every time we are checking, we are allowing to do a transaction, right? So that is the reason. So we have to trace this. Let me do one thing. Just printing the balance. We'll see how many times balance will get printed. 500, 0 and minus 500. Right. So this transaction only is, this is the extra that we are doing in this scenario, right? So Ram is going to withdraw 500. We'll do. We are having less than 1 minute. Okay. So probably one, two, three, four, 5.